Joseph, welcome to Mitiga Mic.
Hi, thanks for having me.
So, Joseph, before we get started, maybe you could give our viewers a little bit of background about who you are and kind of your journey and what you do today.
Sure. So I am I guess you can say reformed cybersecurity practitioner. Um, I started way back in the 90s, pre Y2K. I got into IT and then very quickly transitioned into cybersecurity, leading up to Y2K. And I was basically an operator for about 20 something years. Doing military and civilian. So I was in the Army Reserves. I retired after 22 years as a major. First, I was a counterintelligence agent. Then I got my commission and became a military intelligence officer. And then the last 8 years of my career was in cybersecurity because I had stood up this thing called information operations, and part of that was cybersecurity. And because of my civilian job doing cybersecurity, I shifted over to it. And so I did a lot on the private and public sector side. I've worked mainly financial services, financial institutions. Um, Several different banks. I also worked for defense contractors, all doing cybersecurity. And then I shifted focus and went and got recruited out of a SOC to be initially a sales engineer for this company that sold deception technology. And then I shifted over into marketing. And so for the past 8 years, I've been doing product marketing for cybersecurity products. So right now I'm at Bastille Networks doing uh, product marketing for our wireless security products.
Awesome, awesome. Well, I want to really dive into the wireless side. And uh, in our conversations, you always make it very clear that wireless isn't just Wi-Fi. And I think a lot of people think, oh, it's just my Wi-Fi access point, but it's so much more. It's a big spectrum.
Yes.
But what organizations usually deploy to cover wireless security? What are some of the ways they approach it?
Well, so back when Wi-Fi first started becoming really prevalent and started moving into the enterprise, there were different versions of encryption that they would use, right? So and authentication. So you had like WPA, you had WEP, you had WPA, you had WPA2, and now you have WPA3. Plus, you have all the enterprise level things that they would use to secure the communication. So first of all, they would start with encryption, right? You'd make sure at least that you're using the built-in encryption and protection mechanisms for authentication and encryption within the protocol, and whatever your hardware supported is what you had. Unfortunately, a lot of those protocols did have weaknesses. Like, for example, WPA2 and lower. um, One of the things that you could do for an evil twin attack is you could de-authenticate everybody that's connected to an access point
Hmm.
using WPA2 or lower by just broadcasting a mass de-authentication signal. And so there were all these little weaknesses. And so they started adding other things, like you would add WIP, like wireless IPS and wireless IDS. So the goal there would be try to detect unauthorized access on wireless and Wi-Fi, and then try to detect it and then go and try to find it. But in order to find it, you would need a finishing tool, right? We call it a finishing tool, where you'd walk around with things like a yellow jacket or one of those devices, handheld devices, where you would walk around, and essentially it was an RF direction finder until you could find the emanator, that antenna that was transmitting, right? So you would do that WIPs and WIDs. And you'd also do things like network segmentation or hardening, so that you would try to prevent lateral movement, at least over wireless networks. Because again, at some point the wireless network would have to connect with the wired network, right? And so you'd be getting onto a switch network, and so you can at least limit that lateral movement with proper network segmentation and hardening. You'd have the internal network firewalls, you'd have the rules on your routers, and then you'd have like you know other things to prevent that lateral movement. And then you'd also add like access controls,
Hmm.
right? Because every device that connects to a network is going to have a MAC address of some sort, right? And so you could do a whitelist, blacklist approach, where you'd have access controls, where if something wasn't authorized and it didn't have the right um, versions of software or AV or things like that, and it wasn't an approved MAC address, you would send it off to a containment area where you could then investigate it, make sure that they did everything they were supposed to do to get access to NAC. Or you would do something like switch level security. But of course, since there's no such thing as a wireless switch, switch level security sort of has limitations, and so does NAC, because your MAC addresses can constantly change. They're software defined, so you can change your MAC addresses at any time, and all
Sure.
these other things. So there are things that they would do, but a lot of these things had gaps, and you would sort of have to rely on a full zero trust approach, where you would try to get everything working at an appropriate level to try to protect your wireless network. But
Yeah.
sometimes that approach wasn't always the greatest, but at least you would have a level of security that you could at least be comfortable with, and then any additional or residual risk that you had, you would sort of have to accept or add onto the risk register.
Yeah. So let me ask you. So let's say I'm in SecOps, or maybe I'm a CISO with an organization, and I have wireless. Everybody does, and I'm concerned about what I should do. What are some things that I might be missing? What are some things that maybe I should be considering that maybe most people aren't thinking about right off the bat?
Well, one of the big things is that people, when they hear wireless, automatically assume Wi-Fi. And that's not the case, right? So if you consider what's in your enterprise environment right now, right? You've got people walking around with smartwatches, wireless earbuds, medical devices that have Bluetooth, like a glucose monitor, right? The blood sugar monitor or your insulin pump. You've got smart thermostats, right? All of these IoT devices that are now permeating the enterprise with badge readers, thermostats, cameras, right? Even something as simple as an Ember mug that's used to heat your coffee and keep it warm has Bluetooth, right?
Mm,
And then, of course, that's just one side, because there's two networks in every enterprise. You've got your IT network and you've got your operational technology or OT network. That's your ICS, that's your SCADA, that's your functional devices that technically aren't IoT, but are they're operational technology in the sense that they're part of your infrastructure, and those now come with wireless as well,
mm,
right? So, for example, you know that there are metal fabricating machines that have Wi-Fi and Bluetooth active from the factory built in. And these are fabricating machines that you find on a shop floor that's made to create custom metal fabrication. And yet they have Wi-Fi and Bluetooth enabled. Or you have chillers, coolers for giant data center racks that have a Zigbee console built into them
mm.
so that you can access it, without having to go through the Wi-Fi network. So there are all of these other protocols that you have to consider. Um, and you can't just blacklist Bluetooth because everybody uses it, at least in an
Yeah.
enterprise level. Now, in something like government, you can do stuff like that. You can limit what access is certain secure areas. But for regular enterprises, regular organizations, you can't stop Bluetooth. So there's just no way to do it. You're going to have people wearing, even receptionists have Bluetooth earphones with a mic that they use
Sure.
as they work, right? Right. And then smartwatches and smartphones. A single smartphone probably has like 4 or 5 different antennas, not counting the NFC antenna,
Wow.
right? Because you've got your Wi-Fi, you've got your Bluetooth, you've got NFC, and you've got multiple different antennas for Wi-Fi, Bluetooth. Plus, you have cellular, and cellular is its own little thing because you can transfer a lot of data over cellular. You've got different bands, right? You've got different frequencies, and that's all in your enterprise right now.
Yeah.
And there's not even counting the microwave stuff, right? So you've got microwave antennas that go in, and maybe even Starlink. So you've got all of these different things in your environment, and you're just focusing on Wi-Fi. You're missing like 80% of all of the wireless signals that are in your environment right now.
Yeah. Well, we had a conversation before where you were telling me about some of these cameras, and they can be solar powered, so they don't even need to be plugged in, and
Yep.
they have solar power to charge up a battery, and they're pretty small. They're pretty easy to conceal, but also you can put a SIM card in there, so
Yes.
they're operating on the cellular network. So it's physically in your boardroom or on your factory floor. It's not plugged into power, so it can pretty much be put anywhere in some little nook and cranny, right? And it's not going through your security controls. There's no firewalls or IPS or authentication. It's completely
Yep.
separate, and it records to the cloud. So it's recording audio, video into the cloud with a SIM card on solar or some long extended battery backup. And it's completely separate. It's like it's in a different, it's a multiverse kind of thing,
It's
right? It's
completely
there, but it's
invisible.
not.
It's
Yeah.
completely invisible to your regular security controls because that's what's called a sideband or an out-of-band attack, right?
Yeah.
So I can go and take, and matter of fact, we've found these things. So there's a customer that found bugs in their headquarters
Hmm.
uh, when they first deployed us, and they were audio and video bugs, right?
Sure.
And there are concerns in like government agencies or executive boardrooms and offices and conference rooms and things like that, where people could accidentally leave an AirPod right? And have the mic on and
And you
recording it to
never
this cell
expect
phone,
it
and you
because
would never
AirPods
expect it.
get left all the time, right? They're
Exactly, right?
like you're more
Or a
likely
hearing
to
aid.
find a AirPod or a hearing aid or something than you're not.
Exactly.
So
Right. And the
yeah,
problem is that those operate on a completely different level from your standard network security, right? Now, and that extreme case of a camera with a SIM card on solar backup, recording you from a device as small as, and we've seen these as small as a power adapter for a phone.
yeah,
They sell
wow,
them, right? So there's actually a company in China that makes these things for sale. They're Wi-Fi or Bluetooth enabled camera and audio that are designed to blend in an everyday environment. They look like a plant pot, um, a phone adapter. They even sell cables that, when you plug them in, powers the Wi-Fi or Bluetooth antenna in the head of that one side of that cable, and then you can connect to it remotely. They're called OMG cables or Ninja cables. You can connect to it remote. You can connect to it remotely with a phone with a preloaded set of bad USB scripts or
yeah,
payload that you can just drop by pressing a button, and then that would run on whatever system it's plugged into. And you can do things like data exfiltration. You could launch commands and have it open a website to a watering hole and then close that website, so you would never know unless you were staring right at the screen as that payload happens. And the problem is that a lot of these things will operate on, like, for example, Bluetooth and Bluetooth Low Energy. The really interesting thing I found when I was doing research on about this stuff for a talk is that, the original spec for Bluetooth and Bluetooth Low Energy is 100 meters, right?
hmm,
The current spec, which I believe is Bluetooth, I think it's like version 5 of the spec, is 1,000 meters ideal conditions.
oh,
So
so you could
imagine
be
a
in a
Bluetooth,
parking lot
you
or
could be in a
another
parking
building,
lot
yeah,
and connect to a building like 500 meters away. You can connect to a cable that gets plugged in
yeah,
and run bad USB commands. And then you can do things like, so I can, for example, no one does, like when I did penetration testing, we used to have to like try to exfiltrate data. There's no need to even do that anymore, because all I have to do now is copy that data to an unregistered URL on your web server, and then I can pull gigs and gigs of data, and it's all part and parcel and looks exactly like what your web server is supposed to be doing,
yeah, yeah,
and you would never notice it, because that's what your web server is designed to do. It's designed to give data through a URL, and it doesn't matter what the bandwidth is, because that's the whole point. That's your public presence. And so you
yeah,
can do this through bad USB scripts, where I can just run everything, have it copy over to the web server, run everything, do all of my reconnaissance, install my persistence mechanisms, do everything off of bad USB scripts from a USB cable that is plugged into your laptop from 500 meters away in a parking lot.
amazing. And the thing that I find is most interesting about this, I've seen these OMG cables, and there's no, if you have an OMG cable next to a non-OMG cable, you can't tell the difference. They look exactly the
No,
same.
and so originally it was designed, but so the original cables were designed by the NSA, and they were sold for $20,000. You can buy OMG and Ninja cables for less than 200 right now.
Yeah. And you can fill your backpack up with dozens of these types of devices,
Yes.
and they look like any ordinary device. Now, I know
Okay.
you can buy these
Yeah.
online very, very easily.
Well, so there's a device called the Wi-Fi duck. So you remember the rubber ducky, right?
Sure,
It was
sure.
basically the original design for bad USB was a rubber ducky that looked like a flash drive, right? And you just
Yep.
plug it in, and it had a bunch of stuff preloaded into it, and it would
Yep.
run them, right? They now have what's called a Wi-Fi duck, which is basically what it sounds like. It's a rubber ducky, it looks like, and it has storage, but when you plug it in, it's got a built-in Wi-Fi antenna I can connect into remotely and then run my bad USB scripts. And it looks
There you
just
go.
like a regular, and those are sold for $75.
Yeah. Why try to hack through the front door if you can just use one of these side mechanisms, right?
Well,
Well,
no one attacks the front door. That's like the most protected
yeah,
thing. But
yeah,
all these side channel attacks that nobody's looking for, no one's looking at. I mean, the data transfer rate for Bluetooth is low, but I don't need a lot to capture data, and that's usable, right?
yeah,
If I can get a username and password off of your laptop and transfer it over wireless, then I've got 90% of what I need to do to infiltrate a network,
yeah.
right? You don't
Well,
have to get fancy.
Joseph, as we wrap up here, let's get to the mitigation stage of these, because there's so much right now. People are thinking, oh my God, these could just, I better start checking my cables now, right? So what can organizations do to mitigate this and address these gaps?
Right. So there's there's a few things that you can take some lessons from what the government does. So what the government does is they RF shield, right? So you can set up special areas in your facility that are protected from RF, right? So if that's where you hold your secure conversations, it's where you store your secure files, that kind of stuff, right? So
Like a
and there's a lot of
skiff, an executive conference room,
yeah,
really
exactly.
high. You're not going to do your whole building, probably.
No, but specific high security locations,
Yeah.
right? And you can do things. So there's RF shielding that you could buy, and it comes in many different ways, right? You've got paint that is RF shielded, right? And they've got basically what it is, it has metallic flecks in the mix into the paint, and it
Hmm.
interrupts RF signals, so vastly reduces the range at which they can transmit, and it can actually. So you'll have theaters and like movie theaters and auditoriums painted with stuff to prevent cellular services
Oh,
coming in.
cool. I didn't know that.
As a matter of fact, I was at a concert recently for a quartet. It was at Stanford. So they have this really nice oval shaped auditorium, and you walk in, your cell signal drops because they've
Ah,
painted the inside with RF shielding. You can also use wire mesh. So like certain materials, like even just standard foil back insulation
so it's
is
like a
enough to.
Faraday cage almost, right?
Yeah,
Is what
exactly. You're
you're
basically
essentially
creating
doing.
Faraday cages, right? But
Yeah.
but those are limited in terms of where you can deploy them. The other thing you
Of
can do
course.
is you can deploy. So there's this new avenue of security called wireless airspace defense, and Gartner wrote a paper about it about a year ago. In January, like of 2024, they released it, and then they released some other information on it like mid-year. And basically, what it is it's meant to make you look at the whole wireless airspace, not just Wi-Fi. And what they said was, look, there are a bunch of these security controls, but they don't adequately address the risks that radio frequency risks in your environment actually pose, right? And so they're telling you to go look at things, right? And so they're advocating for these things that look at other wireless technologies, not just Wi-Fi. So you're talking about Bluetooth and cellular and all these other things, and a lot of that inspiration came from signals intelligence and the electronic warfare, which is the military side of it, right? So they brought that in, and what they're trying to do is they're trying to bring it in and say, hey, you really need to look at this and look at what the military and the government has been doing, and sort of look at solutions that can help you with this. And there are a few out there, right? So Bastille does one of those. But essentially, what you're looking to do is you're looking for ways to find emanators quickly, like find these transmitters. You were looking for ways to analyze that data without needing a PhD in RF technologies or being a SIG-Inter or an EW specialist, right?
Yeah.
So things that you can do, you want to find ways that will give you that kind of visibility into the wireless airspace. Because let's face it, we can't see wireless. They can transmit. They ignore walls. They ignore guards, guns, and gates. Right. So your existing security controls aren't going to stop them. And so you need to find a way to do it. And so visibility at the very minimum. Right. And then if you can tie that into your SIM or your SOAR or your video cameras and things like that, now you've got a way to provide that wireless security visibility to all of your other existing security controls. And now you can detect it. Now you can alert on it, and now you can respond to it. And that's really the key there. Right. And maybe you can do assessments like, hey, are there any wireless access points that are running no security or no authentication? Can I find those? Yeah. So there are these solutions out there that you can use, and it all falls under the umbrella of what's called wireless airspace defense. So you really should start looking at that. So there's like the mundane things that you can do, everything from Faraday bags and Faraday cages and paint and shielding and wireless mesh to specific areas, to deploying a wireless airspace that will actually cover your entire enterprise, whatever floors you want, as much space as you want. Like I think one of the things that we looked at is how much actual square footage we cover, and I think we're at 4 million square feet of wireless airspace
Wow.
coverage now, right?
Wow.
So there are a lot of different things that you can do, but really you should start looking at it, because this is an understudied and underprotected area of an enterprise.
Yeah. Well, and the bad guys are counting on it, right? And
Yes,
they're counting
exactly,
on
and
people
they
not
use
knowing
it.
this. Yeah.
Right, and they use it. And there's actually there was an attack back in Thanksgiving of 2024 by this that was published by this security company called Velocity, where a wireless attack was initiated 6,000 miles away, and an APT group broke into an organization by leveraging their neighbor's Wi-Fi network, and then they actually did it to 2 different neighbors to access that target.
Yeah.
It's
Amazing.
called the nearest neighbor attack, and you can probably look it up. But it's just so wireless is something you really should be looking at now, and especially as many wireless devices that there are. And I think the last estimate is at over 60 billion wireless devices, and that number is just going to grow. Like the number of IoT devices that are wireless is expected to triple in less than 10 years. And
Yeah.
we're talking from about 13 billion to about 40 billion
Wow.
in
Well,
10 years, in less than 10 years.
well, wireless airspace defense. Everybody check it out. It's important. And Joseph, you painted a very grim picture. But thank you so much for being part of Mitiga Mic.
All right. Thanks for having me.